we're ready. Let's see. So this is first day of, I think on the syllabus, or not the syllabus, on the, I don't know, course description, it actually calls it additive manufacturing. I think a better title would be additive fabrication, because we're not necessarily going to manufacture anything. But you could use this kind of process to manufacture things if you wanted to, I suppose. But what we're going to do is we're going to look at mainly what's called FDM, so fused deposition modeling or method printing. That's the kind of printing where you melt plastic and build it on top of itself to make different parts. We're mainly going to look at that, but we'll look at other kinds of printing too. Resin printing is another one that we'll look at in particular. There are several other types that we just don't have the, since I'm right here, I don't have a way to demonstrate some of the other types, but those are the two biggest types of printing currently. There are other types. You can print in metal. You can print directly in metal if you wanted to, but not. I'm not going to be able to do that here, so we'll have to just imagine that one. Most of what we're going to do is going to be centered on a FDM type of printing, where you melt plastic, extrude it out in a controlled manner, and lay it on top of itself to build up a part. Let's see. Let's do some of the housekeeping stuff that we have to do first. I've got chat going on YouTube. I have the Discord somewhere around here too. I think I've covered it up now, but so if you want to ask a question, you can use one of those two to ask a question. Hopefully I'll see it in time. Sometimes I forget to look at those, but we'll try to keep that going. On Moodle, there is just really one document that you need to look at so far, and it's just the syllabus, because it kind of gives you an overview. This class is a little bit different. I've got the syllabus on the screen right now, and there I did change the title. That's not the title that shows up on the course description. That's just probably a more accurate title, Additive Fabrication Methods, because we're going to not necessarily be manufacturing things. And like I said, this FFF is the same thing. Sometimes you'll see FFF or FDM. Those are the same thing. FDM was, I think, maybe trademarked, and so people also created this FFF title to mean the same exact thing but not be trademarked. You're gonna build your own printer. Most of you will. It is possible to go through the course without a printer. It just makes it a lot more difficult because a lot of the assignments require you to print something, so you have to have access to one somehow. If you don't have access and you don't have a printer, then we'll have to come up with some way for you to deal with some of the assignments. We'll have to come up with some alternate assignments. So let me know if that's your case, because that would make it a little bit different from what I assume you have. Most of you have a printer, and a lot of you, I think, have the Ender 3. So let's get this off the screen. This is an Ender 3. This is not the one that we'll use in the class. This is, wow, I got to zoom way out. Maybe I'm zoomed in. Nope. This is the one that I used in the summer for a similar class to this one. We built this printer from a box, like this box over here. And we will do a similar thing this time. I just have this one out so that we can actually go through the printing process today, so you can see how it, the big steps of how it happens. This one has a lot of upgrades on it, so it won't be exactly like what we'll start with. Part of what I do in the class is I go through some of the common upgrades, install them. You don't have to at all. You don't have to go and install anything for an upgrade. You can use this out-of-the-box printer, and that will be fine. I just install them so that you can see what they do, how hard they are to install, and if they actually give you any benefit when you install them or not. So this one has a lot of those upgrades on it already, and throughout the quarter, we'll put upgrades similar to these on the printer that we'll build. We'll try and build it today. Usually I can build one of these things in, just 30 minutes maybe. It takes longer when I'm talking through it though. Or I forget something. I've never technically built one like we're going to build for this class, just because it's a different company, but I assume they're all the same. When you get them out of the box, they're all Ender 3s, just maybe branded a little bit differently. So this is kind of what we're looking at for the pretty basic FDM style printer. There's a part down here, can't really see it, but down in this area that heats up. You've got some filament on top. Right now I've got this roll of gold shiny filament on there, and it's just a plastic. It heats up down here and it prints it out on this bed into some shape. I actually don't have anything 3D printed in front of me right now to show you, but it'll print it out one layer. This whole gantry will move up, print another layer, move up, print another layer, move up again, print another layer. Those layers can be really thin. Even on this machine, those layers can be, 1/10 of a millimeter, or typically, that's a little bit thin for what I normally print, just because it takes so long to build something up when you're going that thin. Oh, somebody said that Alvar and Herrick's, so if you're in town, and I think they're A&H Games now, so I don't know if they officially changed their name. I just saw that they changed the title, and they moved. They're over in the shopping center where Beehive is. So if you haven't bought one, they apparently stock them. So you can go over there. And they do, I know they've for several years stocked parts like filament and things like that. And they try, at least they've always tried before, to match Amazon prices on filament. So, and I usually do get some filament from there. I think they have Hatchbox, which is a decent name brand. So here's kind of where we're headed. You don't have to have this kind of printer. There are a lot of different types of printers. This one is one of the cheaper ones, is why I use it. And it's a cheap one, or cheaper, that generally can produce good results. Now it started out as Ender 3. Now there's Ender 3 Pros, Ender 3 version 2s, and the levels above this one get a little more expensive. This one was probably in the $160 something range when I bought it. Now it's got some of the upgrades on here are probably more than $100 just by themselves, because I've changed the board and the screen and added things and all kind of stuff, printed some parts and added to it. But the base level Ender 3 is what we're going to start with, and what we'll do most of our printing on, and then I'll just show you some of the upgrades and how they are to install throughout the quarter. We'll do a lot. I've got a whole stack of boxes back here that we'll go through and see what they are about. Back to the syllabus though, so that you have an idea of how the course works. So this course, like I said, is a little bit different in that you choose most of the things that you want to do. I choose a few, and then you choose most of them. All this is just, your typical syllabus stuff. We are going to meet, I guess, from 8. I put until about 9:15. Today will probably be a little longer because I'd like to get our printer built for today, so you can see the whole process of building one. There are plenty of videos if you don't finish this video watching me build the printer. And if you do have an Ender 3, they're not that hard to build. We'll put the videos on YouTube. They'll stay there, so I'll live stream them so you can ask questions. So there's somebody said in the chat that it's about 200 for Ender 3 there. And so I don't know, but I don't know how many they have, but it's a good, I like that store. And they're in town. The videos will stay. In fact, if you really wanted to, you could go back and watch the summer's videos. If there's one in there that we, for some reason, don't talk about the same thing in this quarter. So technically, it goes from 8 to 9:50. But what I want to do is from 8 to 9:15, we'll do this kind of thing. And then after that, on most Tuesdays and Thursdays, we will do a Zoom, kind of like a class Zoom thing, where if you're in the class, you can ask questions and you can show me things easier, like you have to point to something or whatever and show how, this thing needs some troubleshooting. So that'll be the last piece of the class. There's my office hours. Here's the things that you have to do. So these first 4 are things that I specify, and they're all things that help calibrate your printer. So they're all described down here later on. But these first 4, 5% each, and I give you the file, or well, you download it. It's got a link here. Some of them I say, like these two, I like this thing, but you can choose a different one if you wanted to for some reason. These other two here, probably better do those two exact ones. Well, certainly the first one, because I specify that particular one. So these are all things that help calibrate the printer, get it printing as good as it possibly can. And then there's all these options. So there's 4 options here, and then there's a 5th option that is not necessarily a print. It's more of a assignment, I guess. 2 quizzes, one in the middle, one at the end. And so all of these options, there's a whole list of things that you can choose from. So you have to choose 4 of these, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of them to choose from. And if there's something that you really want to do that's not on here, just let me know, and if it seems reasonable, I'll add it to the list. So you choose 4 of those, and then there's 3 things that are more like a little technical brief, so a little 5-page report. And there's 3 of those that I have to listed. If you can think of another one, then let me know, and I'll see. These are harder to come up with, what they might be, but you choose one of these, so just one of those. And then there's the 2 quizzes. They're in Moodle. They don't actually take class time. They open on a class day, and then they stay open for 24 hours or something like that. They're all multiple choice, and are pretty much all multiple choice. And you do those 2, and then you've got the rest of the syllabus, which is just the regular syllabus stuff. So that's on Moodle. You can look at that whenever you want to. I have gone in and I've sort of set out the sequence of things that we'll do. It is entirely possible, and probably even probable, that some of these will get switched around. Maybe I don't know, the printer might break at some point. I don't know. But this is the order that I plan to do them in, but it may not stay that way. And again, if there's a particular topic that, hey, I'd really like to know about, whatever it is, then let me know. And if it's something I actually know about, then we'll throw that in there as one of our topics. Because many of these won't necessarily take the entire time slot that we have. All right. I talked about there is the Discord server. I like using that just because it's easier than email for most things, like little questions. And so it's always running most of the time. And if you want to ask a question there, let me know. That's easier because I can answer it faster, usually. I have office hours. They were on the syllabus, and so it's certainly open then, and I'm more or less monitoring it. But most of the time, if you ask something there, and other people can, that's the nice thing I like about it, is that other people can answer the question too if I don't see it, or if they have a better answer. So I have that. The link to it is in Moodle and on the syllabus, I think. Or no, maybe it's not on the syllabus, but it's in Moodle. And what else do we have? You can still email me, and we can still do Zoom meetings if you want to. And we do have the Zoom meeting after class. Like I said, today we may not, just because I'd like to get the printer done, but we'll see. Why don't we look at some of the things? We looked at the printer. Why don't we look at some of the things that we'll do this quarter? Let's move this guy back a little bit. I don't know. Let's just pick out some stuff. Oh, Raspberry Pi. So we will set up Octoprint. So there's several of these boxes related to that. So you don't need all of these boxes for Raspberry Pi. Some of these are extra kill, but overkill, not extra kill, overkill. But we'll set up Octoprint. Move this. I gotta move stuff all the time. All right. Which is kind of a remote server for your printer. So you can get on your phone and monitor your print as it's going. You can send it prints if it's sitting there in a waiting state. You can send it stuff to print. So it's kind of handy if you have a bunch of printers and you want to monitor them all. Or a lot of people don't like their printer right beside where they live, because some things that you print can be noxious when you print them. I'm going to mainly print just what's called PLA, which is a filament that is pretty non-toxic, doesn't really smell a lot when you print it, but there are filaments that aren't so nice to be around as you're printing them. So Octoprint is one way to put your printer somewhere else and then check on it and monitor it, send it prints without actually being there. So we'll do that just so you can see how that works. Basically for that, you don't need most of this, you just need a Raspberry Pi. And then the rest of it's free software, and you need a wireless internet connection of some sort. And if you want to monitor it, you need a camera, which I do have a little camera somewhere. I don't know where I put it. A little Raspberry Pi camera. But you could just use a webcam if you wanted to. Let's see. This is, I assume, a duet board. That's what the box says. Let's make sure that's what I actually put in here. Yes, so this is a new brain, new control board. We'll put that in. This is the Wi-Fi version. We'll put that in at some point. It's not one of the super popular ones. I guess it is, sort of, except that there are knockoff brands that are way cheaper. But it's a 32-bit board. And so what that does for us, among other things, is it lets us use different drivers. There are different drivers for the stepper motors on our printer. They are quieter. So when I turn on this printer, it will be much quieter than when we build our other printer. They are 32-bit, so you can process stuff faster. So the G code, the actual code that controls what the printer is doing, can be processed faster. So you can actually print faster in some cases. So we'll put this board in there. I have another board that will print that's a little more on the common side. If I can find it. I think it might be in this box. Yep. This is another board we'll put in. This is the board that's in the printer over here that we've already got built. This is a SKR Mini, specifically made for the Ender 3, so it fits exactly in the box. We don't have to change anything. So we'll put that board in too. Obviously, we can only have one board at a time, and there's a board going to be in the printer, the stock one. It's another 32-bit board. I think it may be about the same price as the Duet. It might be a little bit cheaper than the Duet board. But I like it also. We'll show how that works. And those upgrades, they do make a difference. But again, they're not necessary. I think this is the printer filament. We're going to use yellow. So PLA is what generally I recommend starting with. This roll I probably got from Amazon for like $20 for a kilogram of it. And this 1 kilogram will last for the whole quarter if you want it to. There's the amount of printing that you have to do wouldn't consume more than this unless you choose. There is one option to print something really big as your print. If you want to do that, then it will obviously take more filament. Still, this is a lot of filament, and you can get this, like I said, in town. I think the only place that has it in town is Alvar and Herrick's. If there's another place, you have to let me know. I don't know of any. Most of the time, other than Alvar and Herrick's, you have to order it. Amazon has filament that's fine. And there's a lot of different... I haven't actually ever used this brand, but I'm pretty sure it's a decent brand. If it's bad, then we'll throw this out and get another kind. But expect to pay about $20 for a kilogram of plain PLA. You can get it a lot cheaper. If you go very cheap, unless it's just like a clearance sale or something, then you might have trouble with it because it doesn't have quite the quality control, and it'll have thick spots and thin spots, and it'll just not print very well. Or it's blended with HIPS or some other material that's not just PLA, and it makes it very brittle and hard to print. But it's cheaper material. So if you're paying around $20 for one of the name brands like Hatchbox or hopefully this Solutech filament, then you should be okay. I also get every month one of these little packages that has like stuff to try. So we'll try some different things. So this one's like a really flexible filament. I don't know if it's glow in the dark. It looks like a glow in the dark filament. Yes, it's glow in the dark. A glow in the dark flexible filament that we'll try out. Here's a different PLA. It's a mix of PLA and ABS. Here's a Delrin. So this one we won't be able to print, or we probably won't be able to print on our stock Ender, but later at the end of the quarter we're going to change out our print nozzle and actually the whole print head so that we can print higher temperature stuff. This also needs a chamber, so you might see like heated build chamber is advised. So some materials, not PLA, but some materials need the printer itself to be enclosed in a box so that the whole environment that it's printing in is kind of hot. And so if you see filament that needs that, then unless you're willing to build some kind of box around your printer, then it won't print as well as it could. ABS is one filament like that that's pretty common, but kind of needs an enclosed chamber to print. You can build them. Some people just throw a garbage bag over the printer and now it's enclosed, and they use the heated bed to heat the chamber. This is just this is, I think, Uncle Jesse from YouTube. I think this must be his color. Maybe, well, maybe not. I don't know. It's Jesse PLA Blood Red. So it's just a different color, Blood Red. So I get these little boxes from time. Here's another one up here. It's just a maker box, I think is the, yeah, maker box. And so every month, or whatever your subscription says, every whatever, they send you a couple of filament types, and you just get random stuff to try. So there's a shiny biofusion. I don't know if there's anything special about it. I think it's just shiny. Here's a this one's poly. Oh, I haven't seen this before. PCL. Oh, it's a low temperature. It prints really low. We'll have to try that. This one is a gradient one, so it starts out kind of bluish and goes to a more light purple color. And it's got glitter in it. So if you don't want to buy a bunch of filament to try different things, then these maker boxes are one way to get an assortment of filament. Maybe not the best value. I don't know. I don't know how much they cost anymore. I just have an auto thing for it. This is probably one of the most common upgrades, and it's one of the first ones we'll do. This one is a BL Touch. So it adds this little sensor on the side of your printer. In fact, you can see it over on this one. It's right there. And what it does is it goes around. You'll see it when we start our print up. It goes around and detects where the bed is at, because obviously the printer, for the most part, doesn't have any feedback. In fact, it has no feedback. On the stock Ender 3 printer, there's no feedback at all. So it has to assume everything. So there's limit switches normally, little clicky switches that tell it where the end is and where the top and bottom and the back of the bed and things like that. But the bed itself may not be level. It may not be flat. It might be all warped and healed, valleys and all that kind of stuff. So this little probe can go in and tap on it and kind of map out the bed. So it's a common upgrade. It's not super essential for the Ender 3 because the Ender 3 doesn't have this big giant bed. It's kind of big, but not. There are certainly printers with larger beds to print on than this, and the larger the bed, the more likely you're going to have it uneven somehow. But we usually put one of those on so that you can see how they go. I don't know. There are knockoffs of those too. The knockoffs of those are risky. They don't have quite the quality that the actual Ant Lab, I think, is the name. Well, I got this one from Creality, but it is the real deal one. I can't remember some of the knockoff brands, but some of the knockoff brands do fail more often. And I think I don't know, maybe they're in the $30 range, $40 range. I don't know. I don't remember. See what's in this box. Oh, just cable chain stuff. I didn't put cable chains on the printer we built last time. Maybe we'll print it on this one. There are certain wires, like right here, mainly, and then at the back, that have to be managed. In this case, I just managed them with zip ties, but there are some cable chain setups. I don't know. Sometimes I add those, sometimes I don't. You can actually print cable chain stuff. This one's not even been opened, so I don't know what's in here. Came from E3D. Let's see what is in there. it to open. All right. I don't really. Some of this stuff. Oh, okay. This is for the end of the quarter. So, what's in here? Giant fan and a water reservoir. So this is part of an upgrade for the end of the quarter where we're gonna put a water cooled hot end on this so we can print really high temperature stuff. There's somewhere in this box, hopefully there's the nozzle, the hot end itself, because this is just the cooling side of it. But hopefully at the end of the quarter we'll have that. I don't see, oh, this must be it right here. The Titan Aqua. So, well, it's not assembled, so we'll have to build it. But there's all the pieces to have a direct drive, water-cooled hot end. So we can print really, like we can print PEEK and some of the exotic materials that you just can't print on a stock printer of almost any kind unless it's one of the way more expensive ones. This is not one of the cheaper upgrades though, so you really have to want to print high temperature filament to be able to add this on, because it does cost more than the printer that we're starting with. No, these are just couplers, solid couplers. We actually can add that on in early on. Oh, this is an upgraded bed kit, so there's stiffer springs for underneath here to keep it more rigid. Once if you have added some kind of automatic bed leveling sensor, then you don't want the bed to move at all. You can have it as flat as possible and as rigid as possible, and then go just figure out where it's at by tapping on it. So this is an upgrade kit to make it more stiff. What do we have? Oh, this is a dual drive capstan top. Oh, I've already got one on this printer, so we can look at it. It's kind of back in the back though. It's right there, right there. So it replaces the stock one, and it has geared drive so that it's pushing the filament on both sides. All of this will make more sense as we get to it. Hardened steel nozzles for the nozzle that starts on your printer is brass for most of the time, unless you've upgraded it or bought an upgrade. And brass is fine for most everything, but for higher temperature things, the brass, I mean, it's still okay for most everything. The downside of brass is it's softer when it comes to if you want to print anything abrasive. So there are filaments that have metal filings in them, wood filings in them. Even the glow-in-the-darks has stuff embedded in the filament, and all of those are abrasive, and they eat the nozzle. So the nozzle has a 0.4 millimeter hole in it, at least for most nozzles, and it eats it away and makes it bigger, and so your prints don't come out the way you expected them. This is a tensioner, so back here it adds a way to easily tension this belt with a screw. That's a relatively cheap upgrade that's handy. These are, instead of springs, we will just have solid silicone boxes right there. This is another part of the duet board. Not actually sure what's in here. Well, let's see. Oh, it's an upgraded screen. So a much larger screen. We'll actually have to print an enclosure because it's not going to fit in the stock spot. But it's a giant touch screen. In fact, I might have to get a smaller one to drop in replacement versus if I want to print one. This printer does have an upgraded screen. It does have a touch screen. It's just a smaller one than what we start with. This is going to be a bed. So one of the things that you could do is, right now I've got a sheet of glass on here. It does not come with that, so it comes with just a regular plastic type material, fiberglass reinforced plastic bed usually is what's in there. I've just added a from a picture, a cheap picture frame from probably from Walmart or somewhere, and cut out the right size glass to put on here, and I'm printing directly on top of that. This one is probably a special version of that. Well, there's two of these boxes. So one of them's probably the glass bed, and one of them is probably a removable bed. So a magnetic bed where it just magnetically sits down, and then you take it off of there, and it's a spring steel, and you can easily pop off the prints once you're done printing them. And then this box, we'll open it at the end. That's our, oh, actually there's another box down here. This one is just, this was a, well, I don't see the name. There it is, Monoprice. This was a Black Friday sale printer. This one is a different style. It's still FDM. No, you don't have to buy all these. You don't have to buy any of these. So somebody asked, do we have to buy all these? No. The whole point is I will buy them, put them on the printer so you don't have to. You can see, hey, I really like that one. It wasn't too much and it wasn't too hard to install. Then you can buy it. So no, you don't have to buy all these at all. This one is a Delta printer. So it's a different style of mechanism that controls the movement of it. So I'll unbox that and build. Actually, it's probably already assembled. There's probably no building to it. But we won't do that today. Somebody asked what we should buy. So what you need, what you have to have is a printer, and the Ender 3 is fine. And then most of them today, we'll have to open this one to see what comes in it, but most of them come with some kind of little nippers like this. Seth says that you might have to buy a new motherboard. It is possible that, you know, there's a broken piece or even, I don't know, whatever. But assuming that everything's fine in the box, then really all you need to buy is one roll of filament. Now, you might get tired of printing in that one color. What I normally do if we were on campus, the class will like peel off 15 meters or whatever, some length of filament, and kind of have a filament exchange. Some of you are on campus and you can probably do that. Otherwise, you're just printing everything in, and I picked yellow, so we're going to print everything in yellow on our here, and except for the times we try other materials. But rarely that's all you need. There'll be a little sample of filament in the kit most of the time, but it's usually not a whole roll unless you bought a higher end printer like maybe the Prusa or something. But assuming you bought an Ender 3, there's probably just a little, not even on a spool, just a little roll of filament that will get you through enough to print one or two things just to see if the printer works. But this is about all you really need to buy. Other things that I like to have that don't come in the printer kit, I usually like to have some IPA. This is the 99%, but anything. And I put it in a spray bottle, and I use that to clean the bed, because one of the things that you're going to have problems with is getting the part to stick to the bed as it's first starting to print. And a lot of the problems with that are the bed's just not clean. It's got grease on it. It's going to be unlevel or things like that. We can kind of deal with that, but I usually clean the bed with something like this. Or actually, IPA is hard to find right now just because of the a lot of it's being used for making cleaner. You might can find, these are the same thing, but they're the little, like you're about to take a shot or whatever, and they wipe you down with this. These things work as well. But generally, if you have some, I just put a little spray bottle, spray the bed down, wipe it off, and then I'm ready to print. But other than that, everything, most, like I said, most even come with these. The Ender 3 does use the little micro SD. Hopefully they gave you an adapter to get from micro SD to your USB on your computer, because most computers aren't going to have a micro SD slot on them. So if it doesn't have an adapter, then you'll have to come up with one of those. But most of them even throw that in there now. We'll see what's in that one shortly. Right now, what I wanted to do is I wanted to show the process for printing. So let's get this guy kind of in the middle. Now this one, since it has the upgraded control panel over here, it will use a regular USB. Let's turn it on. That little clicking, that was the BL Touch, just checking to make sure that it was functioning. You know, it had a startup routine. And I do have a touch screen over here. I'm going to take you over to, I'm going to go to Thingiverse. So Thingiverse is, it's not the fastest site, it's not the best site, but it is probably the, I don't know if it's the largest site, but it's one of the largest sites for getting free models that you can print. They're ready to print, or at least they're ready to be sliced to print. So the general start for printing something is you have to create some sort of geometry that you want to print. So you go to SolidWorks or Tinkercad or Fusion 360 or whatever it is, or you just download something. We're going to download something today because we will actually go through, part of the class is going through some of these other software pieces and doing some of their special features. But today we're just going to download something. I want to download something not too big. I'm going to get a coin. If I can type. There we go. Here's the Pirates of the Caribbean coin. I'm not going to print that one. This one actually is a good one for a reason that you might not think of. Maybe sometime print this one flat, like it's shown in the picture, and then print it again standing up on its edge and see how it comes out differently. But that's not the one we're going to do. We're going to go, maybe it's on the second page. We're going to do these little Dwarven Gold RPG coins. We're going to do one of those. They even have gold filament, sort of gold filament in here. Not yellow, though. Oh, this one's in multiple pieces. Let's just print the top piece. Apparently you assemble this. Oh, because it's got a back on it. So this is one of the things that you'll start to see about 3D printing is the printer can't print in midair. So there has to be some way, if you have a part that's going to have a piece that needs to be in midair, then you have to figure out a workaround. So in this case, what they did is they built a ring and a top and a bottom, print them all facing up, and then glue it together later. Let's just print just this piece. So in the thing files over here, it looks like this one. I'm going to download this. What you're looking for is something called an STL. That is a file that is the geometry, but it's all just triangles. So it doesn't have, it's not straight SolidWorks or something like that, or AutoCAD. It is it doesn't care what package it was created by. It's just triangles. So I've got that downloaded, and then you have to do what's called slicing the model. So the next step would be to go to a program. I'm going to use a free one. Most of the things I'm going to do are going to be free, open source type things. Obviously the upgrades are not free. There are some upgrades we can do that are essentially free because you can print them yourself. But let's go to Cura. It is, where is Cura? Right here. All right, so this is a free slicer, and it's one of the more popular ones. There's, I don't know, 5 big time slicers. This is one of those, and it might be the biggest one. We're gonna bring that model. It's probably in my downloads, I guess. There it is. And so it shows up down here. So there it is. So I'm not gonna, we will go through all of these little boxes and what they do. I am going to not do that today. We're just going to try to show you the general process, and then we'll go through all of these little boxes on what we might do. I'm going to set this up in a way that should be okay for this thing to print. So what this process is going to do, there are all these settings. Let's print it a little bit slower. That control how this solid geometry gets turned into code, G-code in particular, that can be read by the machine and interpreted into movements and extrusions and heating and all that kind of stuff. So I'm going to hit slice. You know, it doesn't matter that you don't know what buttons I've clicked yet. By the end of the quarter, you'll know all those buttons. So it says it's going to take me 9 minutes. So I've got that file. I need to put it on the printer. So I'm just putting a USB drive in. I'm going to save it on there. I don't even know what it called it. What did it call it? Oh, CE3. So that's Creality Ender 3 Coin 2. All right. So we'll eject that. Now we'll go over here. And again, the Ender 3 by default, we're going to have to use the little micro SD, and it goes in down here. But now this one's not the default Ender 3, so it's got some stuff added to it. And there'll be a sequence of button presses over here to basically select the file you want to print, and it's starting to print. So let's see if I can get you where you can see this screen. It's kind of washed out. I don't know if I can adjust the expose. Oh, that's making it worse, isn't it? Let's turn it down. All right. So what you've got on here is, and again, this one is a graphical one. The one that we start with will basically be like an old LCD screen sort of type thing. Well, with the, you'll see hopefully today. But it's going to have information like the bed. This bed on the printer heats up. You don't have to heat up the bed for PLA, but it helps the parts stick down a little bit better. So it's heating up to 50 degrees. These are all in Celsius. So 50 degrees Fahrenheit doesn't seem like much, but 50 degrees Celsius, the bed gets kind of warm. The nozzle, once the bed gets up to temperature, the way the code is written, this nozzle will start heating up. It's going to heat up probably to 220 degrees Celsius. So it gets very hot. So there is a little bit of like heat danger with a printer that you can avoid just by not touching the nozzle. There's really no reason to touch the nozzle. That is one thing. Oh, there is one thing I usually buy, which I don't see right now. I don't know where I put it. I usually print these little trays, and it's not in there. I'll have to find it because I've lost it. But tweezers. So some long tweezers so that you can get, let's go back to the bigger view. So that you can get in there, and as you're heating up this nozzle, which it's not doing yet, but it soon will start heating up, filament from the previous print will start dripping out of there, oozing out. Not dripping, but oozing out, and you want to get that out of the way, which you need tweezers for, which I don't know where I've put them, so I'll have to round them up. Oh, here they are. So I usually get some little tweezers so that I can get under there, and well, it's not heated up yet enough. But other than that's the only other thing that I would recommend that doesn't usually come in the kit. Now maybe they do. I don't know. We'll open the kit and see if they're in there. But if they don't, then that is pretty handy to get in there and clean junk off the nozzle before it's starting to print, because it does get really hot. And it cleans off a lot easier when it is hot, because that's when the plastic can actually be melted and pulled off of there. So see, all of that junk was on the nozzle, and I don't want that in my print. So we're getting close to it being up to temperature. It continually oozes until it starts printing. So you it's nice to get in there and clean off the nozzle. I think it's clean enough now, and it's almost up to temperature. So this one is going to go through. You'll get to see the BO Touch in operation. That normally doesn't happen on the start of most prints, because you don't start out with a bed level sensor by default. Some of you might, like if you got the Ender, I think the Pro already has one on it, probably the Ender 2 or Ender 3 version 2, it might come with one also already installed. I don't know. All right, we're at 198. There it goes. So now it's doing a homing routine. Like I said, it doesn't have any feedback other than clicking these little switches to figure out where left and back are. Here it's going to find out where the center of the bed is. And again, it's using the BO Touch. Normally there'd be a sensor over here that would trigger. All right, so now it knows where the center of the bed is. And since this one does have automatic bed leveling, it's going to come and probe. I think I have it set up to do a 4x4 grid. I've got it going pretty slow, so you can speed this up a little bit, but then you lose a little bit of accuracy. Obviously, if you're going faster, you're going to not measure quite as accurately. So I've got it going pretty slow. But it's going to see it's probing, and what it's doing is it's creating this map of the bed based on wherever it touches the bed. And that way, if the bed has high spots or low spots, or if the whole thing is tilted or something like that, then it can, as it's printing on the bed, it can make the nozzle move up and down to trace the contour of the bed so that the part is more likely to stick on it the first time. Now, I've got a sheet of glass on here, so generally glass is pretty flat, and you don't have to worry so much about the ups and downs of the metal. The metal bed, the thing with it is they're usually aluminum, and as they heat up, if you're doing a heated bed print, that aluminum bed is going to absorb a bunch of that heat and deform. So it will start out one shape, and then as it heats up, it will enter a new state of, deformation. And so that's hard to deal with because it doesn't always deform exactly the same every time. I mean, it's close, but that's why on a larger bed, these automatic bed leveling sensors are pretty valuable. On this side, you put a piece of glass on there, you print on top of that, and you're probably fine without the bed level. This is a super cheap upgrade, assuming that you're comfortable cutting glass. You can buy sheets of glass, already cut to the right size. But this really is just the center part or the corner part of a Walmart picture frame. But you have to cut it yourself, right? So it's got one more here, and then the back row, and then it's going to start its purge, and then it'll start its printing routine. And once it starts, and we look at it a little bit so we can see what it's doing, normally you want to watch the start of it, and you'll be able to tell over time, you'll be able to tell if the print is going to succeed or if it's going to have problems. This printer, generally, with all the stuff that's on it, it's generally set up to where it's going to be fine. I could just leave it alone and let it do its thing, but this is the first time it's printed today, so I'm going to watch it and make sure it starts right. Alright, so now it's going to come over here and purge out some of this filament that is in this tube, hopefully. I don't see any coming out yet, though. There it comes. Alright, so it's just driving across the edge there and spitting out filament. There's the filament it spit out. And now it's printing in the center. And what you want to look for, you can't see it because it's underneath this thing. But what you want to look for is that it is squished down to the glass, but not so much that it's barely extruding any plastic. This one looks pretty perfect, so I'm going to let it go. I'm actually going to move it out of the way, and let's start looking at our... It said it was only going to take 9 minutes, so let's just move it back. And let's see what's in here. So we'll have to zoom, there we go, maybe like that. There we go. So this one is an Ender 3. Actually, the box says Ender 3 Pro, but that's not what I ordered. I just now noticed that. I didn't want the Pro. Huh. Well, let's see what's actually inside. If this is a Pro, then that kind of defeats some of the things I wanted to do. I don't know, we'll figure out something. I actually wanted the cheap one. But it could just be they use the same box for everything. Alright. The picture on the box doesn't make me think that it's anything different, but it could be that the Ender 3 is basically, what they sell now might just be Pros, I don't know. Alright, so we got some packing material. Alright, so here's that bed I was talking about. There's I don't know what this is going to be. It looks kind of like a sticker of some sort. Free product giveaway. I don't know. We'll look at that. All right. So here, got the screen, little control board. That looks like the regular board. Not the control board for the brain, but for the screen itself. Some rails. This is going to be the rail that the carriage rides on, and the rail across the top. I actually think I had those backwards. I don't know. Packing material. This is the power supply for it. If I can get it out. Maybe I can't. Well, let's take the center part out first. So this, the bed, the base is all pre-assembled on Ender 3s. So it's one big piece here. But there are cables that you have to make sure are not hung up on stuff. Oh, all right. So they've actually got the print carriage is also part of this package here. All right. So all of this is all one piece. Let's get it out. Oh, lost a bed knob here. Or maybe they don't install it for some reason. I don't know. This one's hard to come out. The power supply. So these things, there are some kits where this is not built for you. You have to wire it up. So, and they don't have this shield on them. Some of the first kits that I built were just like a PC power supply that you wired the mains power directly to. So if yours is like that, then be very careful with that, because it's got 120 volts going, you know, just right across in here. Now these, they've enclosed everything, and it's better than it used to be. But if you do have an older kit, or a kit where you're wiring the mains voltage into here, then you do want to be careful on those. What I generally do is I wire it up, and then I hot glue over all those terminals to kind of insulate them. The other thing with these is that by default, pretty much all of them come set up for, and this one's the same way, set up for 230 volts. That is not, or right there, that switch, 230 volts. That's not what in the US we operate at. We operate at 110, 115, 120 volts. So you have to slide this switch over to the 110 side, or it won't, it's not going to work right. So I might have to find a screwdriver to do this. No, there we go. So 115, now it'll actually do what we want it to do. It wouldn't hurt it if it was set to 230 and you plugged it into 115, but it wouldn't work either. So here, here's another big piece. This has got the X and Z axis on it together. Here's the, well, no, this is just going to be the X axis, or the X axis back and forth, and the extruder. So one thing you want to look for on these extruders is this part. This is one of the pieces that I'm going to replace later on, but it's all plastic on the Ender 3, and if yours doesn't have the little metal insert here, over time the filament goes in this hole and gets pushed out here to your hot end. If that metal insert is not there, the filament is going to cut a groove all the way through this thing eventually, and you'll have binding problems. So if yours has just plastic piece right here, then it's at some point you're going to want to replace this. They're you know, $10 or $15, and it'll be a while, you know, before you need to replace it. But now they've started shipping most of them that have this little metal insert that keeps the filament from cutting away this groove in the thing. Let's see. Let's move this one out of the way. All right. Here's the Z axis with a coupler on it. I'll start with I'm going to build it exactly stock, and then we'll gradually change things out. So this coupler is one of the things that we'll change out early on, just to make a solid one instead of one that has a, this one's mostly solid though. One of the carriage axis. This is a filament holder for the top. or the spool holder. This is just a little pre-assembled axis. Oh, sorry, so some of the tools, it does come with a little scraper. Sometimes you have to scrape the prints off. I generally don't have to, but sometimes you do. Let's see. Got some more rails. Oh, be careful with this. So inside these rails is where they put the Z-rod. You don't want this to be bent because this is what controls the Z-axis going up and down. So don't drop it out on the floor and bang it up. It does look like it's, you know, got a sleeve that's going to keep it safe. I did drop another piece though. Power cord. If you accidentally ordered the EU version, the European version, what you'll need to do is get a different power cord because it's going to not have our plug-in on it. But that's all. It's just a regular PC power cord, so you probably have one laying around. Just sometimes you do that on purpose. You order the EU version because it's a little bit cheaper, and the only thing is you have to replace this cord. Oh, okay. So here's our stuff that we get. We do get the SD card adapter, so that's good. Here's the filament. So this is how much filament you get, at least in this kit. That much. So it's not going to print very long. It's just enough to see that it's going to print or not. We've got a couple of fittings, a couple more pieces, smaller pieces in this bag, and we do have the adapter to get from micro SD to USB. Some hot end socks. So these are silicone socks that will cover the hot end to keep it well, to one, to protect you, and two, to keep its temperature more stable. And you've got some replacement hot ends, so or nozzles, 4 little brass nozzles there. I assume they're all the same size. Normally they're stamped on there, but I don't see anything that says what size these are. But by default, if it doesn't say, you can assume they're 0.4 millimeter nozzle diameters. A whole bag of screws and zip ties, a couple of, you know, stamp tools and stuff like that. All right, anything else? No. So this is our printer. And this guy finished up just now. Oh, but it didn't stick. All right, so this is something that happens sometimes. So on these, I didn't really pay that much attention to it. And like I said, it was the first print of the day. So it stuck for a while, but this doesn't have a lot of area. I should have probably either made it squish a little more or maybe print some more removable material around it to keep it stick down. But this is what happened. It stuck down for a while and then it came loose, right? Oh, I didn't clean the bed either. I told you that at the beginning and then I didn't do it. And so you end up with this blob. Why don't we clean the bed? So all I do to clean it is just spray it down and then wipe it down. And now I do see there's dust all over this bed, which could certainly make it not stick. We'll just try to print the same thing again. All right, while we're working on our printer here. See what time it is. I don't know that we'll get it all built today, but we will try. And I've got to find that part I dropped. It was this thing again. All right, normally there's some instructions. Let's see if we can find the instructions. I assume they're in this bag. Okay. Okay, that's, I don't know. This is the Sane Smart is where I ordered this from, so I don't think that's any instructions. They will all come with some different kind of user manual. Some of them come with a big poster. Some of them, it's on the SD card itself. Some of them, it's a book like this. So apparently this one has a book. And it goes through, you know, these are all the parts it should have. I think I saw all of those parts in there. Then there's usually a little chart for if you don't know the different screw lengths, then it's usually showing you that. All right, and then there's our instructions. Now our printer, meanwhile, has started printing. Once it gets to actually print, it's going to go probe the bed again, right? But once it actually starts printing, this time I'll show you a feature that we can add that will help us keep this thing stuck down. All right, so on our printer, it wants me to get the base, the left and right uprights, and 4 of these M5 45s. So let's see. Wow, this bag is stuck. There we go. You probably want a little bit bigger table than what I've got right here to assemble on. This is kind of... Oh, and it does... This kit does come with a set of nippers right here. These are pretty handy. If your kit doesn't come with one, then something like this for cutting filament. So you find that you have to cut filament a lot, or maybe you have to cut a piece of support off of your print. And it doesn't have to be anything fancy. These are definitely not fancy, but they will do what we need them to do. Let's see. Let's kind of get our stuff organized here. Oh, and they've started, they didn't used to do this, but they started labeling the bags. We're looking for M4 45s. You do get tools. If you have your own tools, definitely use them, but we'll use these. It is handy to keep up with these flat wrenches because there are a couple of adjustments that sometimes you'll want to make where a regular wrench doesn't fit very well. So it is handy to keep up with these flat wrenches for adjusting something later on underneath the bed if you need to. Still haven't found our M4x4. There they are. These are really long ones. Oh, if you don't know how to read the screw, M, it means it's metric. 4 is, or well, this is M5 actually. M5 is the, how does it work in metric? It's the threads, no, it's not threads per millimeter. It's, oh, I can't remember now. And the 45 is 45 millimeters long, but the 5 is the pitch, basically. I just can't remember how it's measured offhand. Oh, the 5 is the diameter. They do pitch a different way. They just have standard pitches, and unless it's something other than standard, then they don't list it. All right. Now what I'm going to do here is, last time our part, I've already thrown it out, our part stuck for a while and came loose. So I've got a feature called baby stepping on here, which lets me, as it's printing, lower or raise the nozzle. So I'm going to actually lower it 1/10 of a millimeter so that it'll print 1/10 of the millimeter closer to the bed, which should squish the filament down against the bed stronger and hopefully make it stick better. And we cleaned the bed this time. So hopefully this time we get it to print. All right. Or we get it to stick and finish printing. It printed last time, it just made a mess. All right. Oh, this little guy put somewhere, this is for cleaning out the nozzle. So it's, I guess, somewhere around 0.4 millimeter. Uh-oh. I think it's having some issues. Well, I'll let it go. I'm not worried about it. So, I didn't clean the nozzle off on the printer, and it had a little, you know, some of this stuff was still left on there, and it is dragging it across the print. So we'll probably end up with a messy print, but I'm going to let it go. So this is, sometimes you do have to clean those nozzles out and this will help you clean it out, but it's super easy to lose because they're really thin and tiny. So put that somewhere. Let's get our base. All right, like I said, they've got wires and everything already routed on this guy. So this part, let's go up higher again. Okay. So this part is the actual hot end. Here you can kind of see what's in there. There's the nozzle, the hot end, heater block. So right here is a cartridge heater. So it's basically just a, I think it's 18 ohm resistor basically. That you run power through. I think these run on 24 volts. So they run power through there and heats up. Right beside it, there's a little thermistor that measures the temperature of the block, or at least that little section of the block, to try to get it to the 220 or whatever temperature you're printing at. Here on the side, this fan, notice it has a duct that kind of shoots air out across here. That's one of the first little pieces I usually change, is print a new duct right here. But this is the part cooling fan. So PLA material, which is what you'll probably print with most of the time, and at least to start with, needs to be cooled while it's printing. And this is in charge of doing that. This fan on the front is in charge of cooling off, like you can't really see it in there. Let's go back to brighter. But that red deep inside there, that's the heat sink. So you don't want, obviously this heat that's being applied to the block, you don't want it propagating up and melting the filament way up here somewhere. So there's a heat sink. This fan needs to be running at all times while you're printing, or else you're going to get clogged. So if this fan is ever not running and you're printing, then there's a very good chance that that print is not going to work. Some people like to take this apart and reassemble it to make sure it was assembled correctly. I'm going to leave it and so assume they did it right. We'll see. This is that silicone sock that kind of keeps this heat away from everything else and keeps it more stable. So see if I can get it back on there. All right. All of this, so when you get this part, you do want to check that the bed is not wobbly, like that's the entire table shaking. If for some reason you get it and this is really wobbly, and this one does have a magnetic bed. See, now I don't like these really flimsy beds, so we'll replace that later, but some of yours may or may not come with the magnetic bed. This one did, but I didn't order the Pro, so I don't know why they sent me that one, but whatever. Underneath here, right there you can see it. Those two, that one, it has a hex shape, and the one behind it has a hex shape. Those are eccentric nuts, meaning that they have a hole in them, but it's not centrically located with the, the outer part of the bolt or the nut. It's a nut. And so you can turn those and bring those wheels like these. Actually, let's do it on this one. This one right here is an eccentric nut. And you might can even pick up how the bolt center is not aligned with what you would think the center of this shaft is. And so what you can do is with those thin wrenches, if something's loose, then you can take and turn this eccentric nut. Let's see if we can make it happen. I don't know if you can see it, but what it's doing is as I turn it, this wheel is moving in and out depending on which way I'm turning it, and it will ride against the rails, closer or further away. I saw some questions in Discord that should you pick a printer other than the Ender 3? It's totally up to you. The Ender 3 is just the main one that we'll use, that I'll show you things on. But there are a lot of good printers out there. I noticed our print failed over here, so I'm going to make it stop. So we'll get back to that. But no, you don't have to use the Ender 3. Oh, requirement for build volume. No, there's not. Any printer that I'm aware of is going to have the largest or a big enough build volume for anything that's required to be printed. There is one optional assignment that is specifically build a big thing, like print a big thing, like if that's just whatever you wanted to do. And I think I said the build volume on the thing you build would be that it doesn't fit in a 5 by 5 by 5 inch cube. So that would be the big one, but that's an optional one. So there's no print build volume requirement minimum. Any printer, the biggest thing that you have to print is actually, I don't have one right here, but it's like that long and no more than 2 inches long and 1.5 inches tall is the required thing. So any printer is going to do that. Any printer that I'm aware of. There might be some really tiny printer that wouldn't do it. So my bed looks fine. It's a little tiny bit wobbly, maybe now that I look at it, but I want to leave it as it is for now. You do have to be careful, like I said, with all these wires they've got already wired up. It's nice they already have them wired up, but they do get in the way. These are the upright pieces here. They are shipped all wrapped up. So we got to get them apart. So like I said, if you've built the Ender 3 before, or built any printer before, they're all similar style now for this type of printer, then it takes you, 30 minutes or so. Obviously, it's going to take a longer time while I'm talking about a bunch of stuff. But if you've never print one, maybe it'll take you, I wouldn't think it would take you more than 2 hours. If you've never built one and you're going really, really slow, I think you would be fine. You could do it in 2 hours. I don't think it's going to take that long, but there's always, a little bit of checking and double checking things and stuff like that. Oh, and if I ever start going and you've got to go, that's totally fine. Just go ahead and go. And like I said, the videos will stay up on YouTube. I don't know if I'll ever take them down. And I don't really ever edit them unless something really bad happens. The software that I used is Cura. It's version 4.8 now, I think. It is free. It's from Ultimaker, so they're another printer company. Oh. But it will work with, any printer, not just theirs. Another good one is the Prusa Slicer. It's a good one also. Cura probably currently has more users, and you can find more people helping with that. Oh, that does remind me. One thing I would say is you should. I don't know if a lot of you use Facebook, but a lot of the printers, Ender 3, Prusa, all of the printers, they usually have a Facebook group that is really good for troubleshooting and just ideas. And so if you do have Facebook, then hunt down the group that's associated with your printer and join it. So these, they look similar, right? But you do have to pay close attention. This one, the one here, has 2 holes in the side. This one has 2 holes at the top or bottom. Actually, they're going to be at the bottom. And so there is a left and right here, even though they look more or less the same. You have to look at the pattern of holes, or else you'll end up having to take it apart. So the left one also, you have to realize which is the front of your printer. Right now, this motor is at the back. So this is the one that controls the bed. Oh, it's tied down somehow. How did they do that? Oh no, it's just stiff. All right, there we go. Now, as I'm moving this, I can already feel like maybe you can see that how it jerks? Like there, it just stops. What they've done here is they put the one of these eccentric nuts on so tight that one of these wheels has a flattened spot on it. So I'm gonna have to work on that because it's kind of clunky. So I'll go in later and loosen up one of the eccentric wheels underneath here. There's 2 right here, and try to get this a little smoother because it's definitely got a flat spot. I can feel it every time it goes around. And if I can feel it, then that means the prints will feel it also as they move past that flat spot. I may even have to replace the wheel. I don't know. Usually you can just loosen them up and they'll, go back to normal. But whoever set this guy up cranked down a lot on the eccentric nut. All right, so these two bolt holes go at the bottom. There are holes here that the 45 millimeter long screws, we have to put this on the side, they're going to come through the bottom and screw into here. And then we'll get our, oh, these do have the swivel ends on them. Sometimes that's handy. It does help if you have somebody helping you build this thing to hold stuff while you're screwing it all together. But you don't have to. One thing with these is some of this stuff, I didn't even check, but some of these can be cut crooked, right? So the ends of these extruded aluminum pieces, if they're cut crooked, then when you go to assemble them, they're going to assemble crooked, and that can create problems as far as binding on the, and this is the Z-axis, goes up and down here, up and down, well, it's off the screen, but up and down the piece that we're bolted on. And so if you have a square or some way to check for squareness when you're assembling this, that will definitely solve some problems later on, because you can figure out that this piece that we just put on is or isn't square with everything else, the assembly. And you can shim it up to make it square. I did not check. I'm just going to build it like it came and see what happens. While I've got it turned this way, I think I will also see if I can loosen up the, because it's going to be easier to get to now than later, except that I've lost my wrench. So inside here, I'm going to move this, and I'm just going to loosen these. Now obviously, oh, that's way better. And it's still not loose, like the bed is still not wobbly. So they had cranked down too much on one or both of these. I'm still loosening though. All right, now it's starting to get a little bit wobbly, so I don't want to loosen that one anymore. But you do want this thing, it doesn't have to roll like completely freely, but you don't want it clunking around either, and you don't want it loose. All right, so I think that's as good as it's going to be for now. This one, the two holes go at the bottom towards the, they're not centered, so they go towards the bottom and on the inside. So you do have to get those. This one has, even if you get it on the right side, you could still put it in backwards. So you have to be careful with it. Those two holes hold the power supply on. If you have to, take it apart, then that's fine. These particular instructions are, oh, you know what? I didn't check. Yeah, these had washers already on the bolts, so they're fine. Oh, when you're tightening these, you do want it tight, but you don't necessarily, want to strip anything. This is aluminum, so it is possible that you over tighten and strip the threads that are threaded into the ends of the aluminum. So don't overdo it for sure, because that's going to be a hard fix to rethread, or you basically would have to get a larger diameter bolt and rethread the threads in there, which is not going to be a simple thing to do. All right, now it wants us to put our panel control board panel on, which I know we had, but now I don't. Oh, it's in the bag. So this guy. And it is going to go on the front up here. And it just has 2 screws that are going to screw right there. And the power supply. They want us to do that also. So the power supply is going to go back there. Oh, mine's got some wires. Oh, so this guy. This is the source on some kits. I haven't seen many lately, but when they first started making these Ender 3s, they would use a unofficial version of this, and they would solder the connections. These do not look soldered. These look crimped. So you want a real XT, what is this, XT30, XT60? XT60 connector. And you want crimped connections. Anytime that I've seen one of these printers have a fire hazard problem, it was this connector. What happens, either that or a bed connector back here. This one is a little bit loose, so I'm gonna have to work on that. I don't want that loose. I don't know why it's so loose. But the power going into the bed is just soldered onto the bed underneath here, and this strain relief is a little bit loose. I think it has to do with the way they've got the bed tightened down. I'll have to check it. But since this moves back and forth all the time, then without a strain relief over here, then those solder connections will get loose, and a loose solder connection requires more power to be sent through it, electrical power, and that more power creates more heat, and so it creates this cascade problem. Same thing on here. So you do want to make sure that you have crimped connectors, not soldered. And I don't think anybody's shipping them with the old soldered on connections anymore, but just check. All right, so this is going to mount up something like that. All right, so we need M5x8. These little guys, the silver ones. They actually gave me 4. I'm not sure. I'll have to keep up with the other 2 because I don't know where they go. All right, these. This is also in my instructions here, is when it reminds you to select the correct voltage. Wow, this is hard to line up without being able to see it. On the power supply, remember we had to flip the switch from 220 or whatever it was to 115. Okay, get that going. Get the other one started. Oh yeah, somebody else answered about the Cura. I didn't realize I didn't spell it out because you might not know how Cura. It is C-U-R-A, and usually if you just Google for Cura, then it'll show up as I mean, that's the only thing I know of that's called Cura. But like I said, there are others. We'll look at some of the others. Other slicers. That's what they're called. It's a slicer. So if you want to look at other slicers, then there are a couple of other ones that have a little bit different features that you might be interested in. All right, so you do have to pull this out because you have to plug this in. So don't mount this and then leave this wire stuck up in here, or you'll not be able to get to it later. All right, so I'm looking for this hole. I want this wire on the inside. It's not wanting to go there though. See if we can get this one started. Something's, you know, they say to do it this way, but this doesn't make sense to me. it would make more sense to have these on the outside to pull this further away. But that's definitely not what they're showing. Very strange. Because it's gonna... I don't know. Let me check this. That is definitely what they are showing. But if you do that, unless there's another set of holes on this thing, that would... You have to have the switch on the outside. But... And there's not another set of holes, but that's going to make it... Oh, you know what? This flexible... This bed can fit other ways, and it would have shifted over. Still would make more sense to have this, just have more clearance, but whatever. This is the way they say to do it. If I were doing it again, I think I would actually put it on the... Put these holes on the outside, but just flip this around. I would put these holes on the outside, but we'll do it this way. It's got some clearance. It's not a lot. We'll have to be sure that if we use this bed, we have to put it on in a way that it doesn't collide with the power supply there. And okay, the switch to select between 230 and 115 does get put on the outside, so it's not covered up. So you can, if you forget, you can switch it after you've installed it. All right, that seems good. So it is getting close to 950s. If you have to go, that's okay. I'll keep doing this just so that it's all here, and if you want to watch it, you can. Or if you want to just figure it out on your own, that's totally fine too. Or if you're building a different printer, then that's fine too. The biggest part of this class is that a lot of it, I'll show you a lot of things, but a lot of it is you get to choose the things you want to do and kind of make it your own. And if there's a thing that I don't have listed, I said this earlier, but if there's a thing I don't have listed, then you know, pick your idea out and let me know what it is. All right, so this is the Z in stop. It's going to go down here, and it's the little switch that's going to trigger whenever the Z axis comes down and hits it. I don't know about this ones, but all the ones in the past, this little notch right here kind of makes it where it can only go so far down. And I've had to cut this off on all the other printers I've built like this. So don't be afraid if you're building everything and it goes to home and this needs to be lower. And in other words, the where it triggers this at its lowest setting, the nozzle is too far above the bed and it can't reach the bed. Then what you do is you take your little nippers and you cut that little piece off. I will leave it on there and see if it's set correctly for this printer, but all the ones in the past I've had to do, I've had to cut that little piece off so that I could move this in a more, more positions. The other thing with these is this is the first time you have to use these T-nuts. So these nuts, you have to back them off a little bit, but not completely. And they slide in these grooves here. So they will slide in. You can actually put them in from the side. I'm going to try to put this one in here. And then you tighten this up and they fell out. So I'm just going to put them in here and tighten them up. And you do have to make sure they swing into place. Otherwise, they just tighten against the plastic here and they don't actually hold anything. These swung into place so that they're across this groove instead of aligned with it. And now the trigger's set. Now this we will have to come back later probably and adjust the height of this so that our Z or nozzle is the right height off of the bed. You want it you want the nozzle to be about, this is thin paper, but the thickness of maybe 2 of these sheets of paper or 1/5 thicker sheet of paper off of the bed. If it's too close, then it can't spit filament out. If it's too far away, then it's just dropping filament on the bed and it's not sticking. We kind of get the kind of problems we had over there, although that was something else. We'll get a good print. I'm not too worried about that. So you do have to, the way you adjust that, if there's no sensors and no other way to adjust it, is you raise and lower this thing. So we'll probably have to change that position at some point. Let's see what it wants us to do now. We're actually relatively close. We might be able to get it assembled in time. All right, now it wants the Z motor. That's this guy. So it's the one with the coupler on it. Now in this coupler, these split couplers like this, there's if yours isn't already installed, there's a large size and the other one is a small size, because the Z motor doesn't have a shaft the size as the Z rod. So this is a lead screw that we need to get out of here. Hopefully it's straight. And then it's going to screw into this coupler. Well, not screw into it. It's going to sit in this coupler. And then we'll tighten this set screw to tighten it. Hold it in place. We've got to find the right Allen wrench. You don't really want the screw to bottom out against this bottom half of the coupler. You want it to stay in its half and this one in its half, so that they're not touching each other. I think I actually have this one set a little bit low. Let's see if I can figure out. Yeah. All right, there. This Z screw, this lead screw, is going to control the axis moving up and down. It is a quad start, I think. Maybe it's only a double start. I don't know. It looks like there's one thread on here, but there's actually 2, maybe 4 threads all wound together on here. Once you do machine design, you'll learn about that. All right. So this is going to screw right in here, and it's going to also use those T screws or T nuts. Or is it going? No, they've got it now where it just screws all the way through. All right. So this one just uses 2 M418s. So in the past they used the T nuts there, but that's what these 2 screw holes are for. So you'll find different versions of this kit depending on, how old the kit that you buy is and where you get it from. And they might have slightly different ways of going together. Now I do have to find those holes. There they go. General assembly tip, when you're assembling anything that has more than one fastener, put all the fasteners in and then tighten them up. Also, when you're starting a threaded screw like this, it actually works a lot better to the first thing you do is actually try to unscrew it. So back it out and the threads will fall into the threads in the hole easier, and then go forwards. Again, don't over tighten. Don't make it loose, but don't over tighten these things either. I would not use Loctite or anything the first time you're building it. Get it all built without Loctite, and then get everything squared up and working. Then, if you want to, go back and Loctite everything down. But there's a good chance that you might have to adjust stuff later. Now we need these. Again, there's 2 of these. These are easier to tell apart because there's a long one and a short one. One is the top bar off of our screen, and the other is the Z-axis. Again, everything is, I should have unwrapped all this, but what I like to do on these videos is kind of do all of the steps, even the boring ones, of all the little pieces you have to do to get this thing built. So this is going to go across the top. Oh, wow, look at that. Those are definitely going to have to spread apart to fit on there. So that means that one of these, or maybe both of these, are not square. All right, this one has an orientation because there are different patterns of holes on the ends. So we do have to be careful of which way we need to go. So that we need, this is the left side where the countersunk one is a little further away from the end. This is the right side. All right, we need to get our carriage, this guy. And it has several, well, this, all right, so I gotta find them. It's gonna bolt, yeah. All right, so this one is set up nice because there are holes on the back where you can put the Allen wrench through to bolt it to the rail here. All right, we need M4x16s. Let's see, these guys. They should have washers on them. It looks like they're already installed and they're captured. I don't think they can come off of there, so that's good. And we have to bolt. Actually, I might have said that backwards. It might be that this is the right side, because now that I look at it, this is the set that's going to line up. So this countersink is going to go over this bolt, so it'll sit on top of it like that. So that clearance there is to clear this bolt. So this one won't actually fit the wrong way, so it'll only fit one way. All right, now it is going to be tricky to get these down in here, screw them in, and get it all lined up. That is a tricky thing. But there goes that one. It's off the screen. I'm getting lost on where the screen is. All right, and then this one is going to be really tricky. There it is. And this is going to have to line up straight, and then you have to reach from in here to get it in there. All right. And then we can tighten those down. Again, these don't have a lot of thread at all in the aluminum bar, so definitely don't overdo tightening these. All right, so that is that piece. Now there's the other end of it, which is the little Y-shaped piece that's I've set the printer on, apparently. This piece. And it has two holes, and it has another bolt that has to be cleared. Wow, I just scraped myself on the printer. All right, so it's gonna, there's that hole, there's the clearance, or the bolt head, the clearance for it. This one will be easier to do. If I can get it straight. I think we will bolt from this direction. Definitely easier than last time. Yeah, I'm just screwing the things together. It's off the camera, but I'm screwing these together. And I assume the next thing is that we will need to put this on the printer, but let's check. Oh no, we got to do the belt. Well, gotta wipe that off. All right, so the belt is a little. It was in the bag. Here it is. It's in its own little bag. So the belt for the Y-axis is already installed down here, but this one for the X is not. And the Z uses this lead screw. So here's the belt. It already has these little fittings on the end. Oh, wow. All right, we can, all right. So it would have been simpler had I already put this on there, but we can back this nut off far enough that it can slide on here. So we do have to get this oriented correctly, right? So this orientation where this on top, this is going to be the top. We don't want it going this way. So this is the top. Obviously the filament's going to come out here, so this has to be here, and it goes in front of the rail. If it's on the back, you know, if it's on the back over here, then it would collide with that. So it goes on the front of the rail. Since oh, it's not in the way because I don't have that on yet. All right, so it won't Let's see if I can get all this where you can see it. It won't slide on here yet. Oh, because a couple of reasons. But what I can do is I can move this with my wrench that I put over here so that it swings this wheel further away. And that should give me, except now my wrench is stuck in there. It should give me enough room to get this thing on. Still, I may have to take it all the way off. I don't want to do that. Let's see if I can swing it any further out of the way. That's about as far as it's going to go, I think. Well, we have a couple of choices. So it would have certainly been easier to put this carriage on before this guy. So let's loosen this up and do it that way. Nope, wrong one. I've lost the correct Allen wrench. Put it over here. So let's loosen this up. It just needs a little bit of clearance that this bracket is not providing. So I don't think we have to take it all the way off. We just have to loosen it. Maybe we have to take a little further. All right, there's what we want. Now let's tighten the bracket back up. All right, now I can show you how these eccentric nuts work. So this is, actually it's on the, actually it's pretty much right. Let me make it wrong so that we can show how it works. So this one's the eccentric one. And if I can, all right, so there. Well, even that's not very loose. Well, I can't make it loose. They've actually got this pretty tight tolerances, but turning this eccentric nut moves this wheel further away and closer in. And so if you get, and this is shaky or wobbly or anything, then you adjust it until it's not super tight, but it moves freely and it doesn't rock back and forth. And this is pretty solid. And it moves pretty freely. So I'm going to go with that. Again, here's the top. Our hot end is on the front. Top for where the filament is going to come in. It's going to go into this tube, down into the hot end, and come out here. And that movement is actually this shield, so the actual bracket is not moving. Now, we need to get our belt routed. So the belt, these little gold pieces are going to fit in these little slots right here. So the belt obviously has a side with teeth and a flat side. The side with teeth, you can tell where it goes in here. It has to go around. That's kind of hard to see. I don't know if you can, there's no light down in there, but this pulley is has those matching teeth on it, so it has to go around that. And then it's going to run through this little channel and come back around. There's nothing on this end yet. We'll put something on here for it to go around, and then it'll come back around and go into the slot. So like this, well, like this, around the imaginary pulley over here, which isn't there yet. And it's going to have to go under the wheels here, which probably is going to be easiest to do if we just drive this across it and then pull it through. Now we don't want it to twist up or twist around anything. So we do want it to maintain that. Now it's going to go through here and around the toothed pulley without twisting. So you got to keep it all flat. And it's going to go around that pulley and then back in there. And it should come out the other, oh, it's wanting to go in the channel. So what it's doing is going in there. Okay, now we got to get it out of there. There. All right. And finally, it's going to go in that little slot. All right. Now, it's really loose right now, right? Because we haven't tightened this end over here. This is all too much to get on one camera. But that is what our last little piece in this bag, that's what it does. So it's got more of those T-nuts. We need to back those off so that they can, wow, that's really tight. So we just back them off until they're still threaded on, but they're not super tight. I'm going to move this closer to the middle. It's kind of hard to move now. There. There we go. All right, and it's going to go in this slot, and it is adjustable. We do have to, so we can pull out on it to tension this cable. It has to go, the cable has to go around this pulley. Well, several things have to happen at once. Let's get this in there, and then, come on. Around the pulley, don't forget to make sure that you're still around this pulley, which I'm not. So I missed the pulley, so I need to get this around the pulley inside here, which I'm working inside here right now. See, the pulley's there and the belt's inside there, which may be difficult to adjust. If I get one of the thin little Allen wrenches, I can pull it on there. May have to go back and all right, let's do this one first. Undo this one to give me some more slack on that end. All right, let's get this one on there. Okay, now it's on that pulley. Now take our slack out on this side and try to get all this together. Move that out of the way. There we go. Now, there we go. Tighten these guys up. That's what it's supposed to do. We're on that pulley. We're here. We haven't tightened this yet though. So there's not really a tool quite large. I mean, this is the screwdriver they gave us, but generally what you do is you put some prying tool in between here, pry out, and tighten these up at the same time. But this little guy is not going to be that tool. And I don't, maybe I could use one of the larger Allen wrenches to apply enough tension. If you, obviously it'll still work if you don't get enough tension on this belt. What'll happen if this belt is loose is that your prints will have like wobbles in them, and it's called ghosting or ringing or something like that. All right, so now we check That seems reasonable. It's not sloppy. The belt is not too tight. It's not too loose. That seems good. Wow. Oh, and it's 9:50. So if you have to go, that's fine. I'll keep going with this. Normally on what we'll do right after we do our whatever we're going to talk about with the printer is we'll open up Zoom and we'll go in and just answer your questions where you have to like troubleshooting type things or whatever you need. I'll keep with this and keep recording it so that you can watch it later if you want to see the rest of this. We're actually almost finished building it. I won't print with it today. I'll print with it first thing on Tuesday though. But I'll finish up the assembly because I don't want to leave it all scattered out like this. So if you have to go, that's good. I noticed a lot of you already did. That's fine. What we do next is we put this on here. All right. So it's just gonna, we have 6 of these wheels now that have to all go around here. So they might need adjusting. This set of cables, cabling and everything. Whoops. I flipped you upside down. See if I can get to the top. There we go. This cable needs to be on the back side of all this stuff we've got here. Okay. And if it's just too difficult, then we're going to need to loosen up some of these. There's a eccentric nut on the inside ones are both eccentric nuts. So we're going to need to loosen those up to get enough. Oh, and we do have to make sure that the Z screw lines up with the threads here. We'll have to turn it. Actually, that was all that was holding us up, I think. There we go. So now I'm turning down here. You can't see them off the screen. But down here, I'm turning this by hand to basically thread this screw and drag it down. Now I've got a bind over here, which I don't like, so I'm going to loosen this one up. Which way is loosening it? Hard to tell sometimes which way is tightening and loosening on these because you turn enough in one direction and it switches from tightening to loosening, so kind of hard to tell which way you're moving them sometimes. But this is still, oh, it's all right. Here we go. We were angled too much, so I've got to make this side on the right doesn't have anything that control. You know, this is only one Z rod, so I kind of have to manually get this one to go. But there's, oh, there we go. All right, now it's moving pretty freely. We'll have to. One of the things that we'll have to do later on is get the, notice how sloppy that is. That's because of the, whoops. See, it can move a lot. That's because of this, well, the combination of these nuts here. So I need to definitely tighten this one up. That's better. That's pretty good. That's about as good as it's going to get. Now we don't want it to bind. Yeah, it's binding a little bit. This one might be. We'll have to adjust on that a little bit because it's definitely binding. What I'm doing, well, now I'm going off the screen again. What I'm doing is I'm adjusting these two. Let's see if I can get it facing you better. I'm adjusting these two eccentric nuts so that when I go up and down, notice how this side's moving and this one's not. I'm trying to get them to where they more or less move at the same time, because you don't want, you don't want it doing one side moving a little before the other as much as possible. So it's going to take some adjusting on getting these nuts the right tension. I think this one's probably still too tight. It feels too tight to me. So I think this one's too tight and that one's too loose. Let's tighten. That one's definitely loose now, but this one I think is part of our problem. Still got a lot of slop over here. I may finish the assembly and then come back and do this, because this could take a while of tweaking. We'll go with this. This is not horrible, but it still moves a lot over there before it moves over here. So, and in general, your printer doesn't sit there and go back and forth like that. So we'll carry on, and then I'll work on getting this, because this is definitely, can't help it. All right. We'll get that better later. All right, we put the top on. Actually, the top might help, because the top might be, not the right distance apart. So there's just screws across the top, and it looks like I do. Oh yeah, I'm gonna need to pull that in, which is gonna make me loosen that one some. All right, this is 4 M525s, which I think are probably the only bag I have left. And in here they gave a few extra each time. So you have a few extra screws in case you lose one or whatever, but there's not that much. I see one of each that's extra. Oh, that's going to be hard to get that to align. I may have to do some more adjusting on this just to get the rails to align right. Maybe if I put it farther to the bottom, it'll give me some enough slack. There's actually quite a bit. This is what I was talking about with these things could be cut unlevel, unsquare, and it causes problems like this that you have to work on. All right. Oh, wrong one. All right, we got it there at least. Okay, now we'll tighten these down. That should help square it up, assuming that these holes were spaced correctly. And that finishes all of the assembly of the mechanical side of things. Well, other than the spool holder. I don't know if I'll assemble that for this class, just because we're out of time, so don't know if I want to do that. And then the rest of it is going to be just plugging things in. And it's all labeled, which is nice. At least on this one, it's all labeled. So the spool holder is just this guy. It mounts right here on the top. and all the cabling is going to just plug in. There's a Z cable, and it matches a Z cable somewhere else that I don't see yet. Let's see. These ribbons are for the screen, so they'll need to be routed in such a way that they can reach the screen. So they'll actually come out this way. This is the power. Well, you're off the screen. So the power, obviously, that's going to plug in there. This ribbon cable is the screen cable. Let's see. This does have a direct, yeah. So that, sometimes you want to mount this somewhere so it doesn't get under the, I mean, you don't move the printer around a lot. You just don't want it getting, you don't want any of the cables, if they can reach it, you don't want them to get hung when the bed's moving back and forth. So I don't think any of those are going to get in the way. This is called the Bowden tube right here. It's the filament is going to travel inside that. So what they're doing here, this is called a Bowden tube printer, where the motor that is pushing the filament through the hot end is not directly mounted on the hot end itself. So there are some direct drive where this motor is directly on the hot end. The good part of that is there's no tube like this where filament can have basically act like a really long spring. So you have more control of the filament over the filament moving. The bad part of that is it adds all this weight to the print head, so you have to print a little bit slower in general because that print head has to move back and forth, and now you're making more weight that has to move back and forth. So these printers are set up with a Bowden style, or Bowden, whichever way you want to pronounce it, and it uses some little fittings that, for whatever reason, they didn't install that. I don't know why. But these little quick connect fittings, I usually do replace these because in general, what the idea is, you push this down and you'll be able to pull the tube out. That almost never works with these that they ship, but actually that's not even the right size for this. So I must have another bag that's got smaller. Here we go. So got smaller ones for this end. So it screws in here, and this tube now can push inside there. And you want it to seat the whole way, and now it shouldn't be able to back its way out. These little clips, these little blue clips, snap in. Can you see that? I don't know if you can see that. They snap in under this lip here, so that one doesn't want to snap. Oh, I've got it. It won't snap in without a tube in there, really, because there's a slot. But it snaps underneath that ring so that you can't push it in accidentally and the tube doesn't accidentally come out. So you put one here and then make a bigger one. On this tube, let's get that one. On this tube, you definitely want to make sure this is seated all the way down in there. If there's a gap, let's see if I can get it out. All right, yeah. So if there was a gap between the end of this, actually, I don't know if you can tell that. Let's see. Let's see if you can see this, because this is something that would create problems. All right, so the end of this tube, it's mostly square with the tube, but there is a little bit of an angle. It's not bad. There's definitely been worse, but that little bit of an angle, what can happen is the filament comes out here. At this point, it's basically in the hot end and it's molten, and it can come out between that angle and the seat inside the hot end, so the top of the nozzle. And then it's outside of your path at that point. It's not in the tube, it's not in the nozzle, it's outside, and it will create clogs. So we need to, I'm gonna leave it like it is for now because I don't have the tool already out to chop this off straight. But check yours and make sure that it's as straight as possible across this tube. And it's not at an angle. Like the angle I'm talking about would be exaggerated, like if it was cut like that. That would be a really bad angle. This one's, pretty close to being perpendicular to this tube, but it's a little bit, it's not that much, but it's a little bit angled. But make sure this is all the way in, seated all the way down till you hit a hard stop at the bottom. Otherwise, you're creating a gap between there. And then you put your little clip in there to keep it from backing out. Well, don't lose it. Put this guy in here. There we go. And they just clip in. Then you can pull them out if you ever need to undo the system. You pull them out, push the thing down, and pull the tube out. All right, that's good. This cable, I don't know if I'll be able to show you this at all, but inside, yeah, I can. Or I can see it anyway. Inside here, there's 3 plugs it can plug into. It's going to plug into, obviously, the most inaccessible one, expansion 3. So it'll only plug one way. It has a little tab on it that goes into a slot, but it goes into 3. If for some reason you plug this in and your screen doesn't work, then you've plugged it into the wrong one of these 3 things. So switch it to another one. It should be 3 though. All right, what else do we have? Oh, we got all this stuff. This motor is already wired up because it came on the base. This motor, this is the extruder motor. So we're gonna need an extruder, let's see, E. So it's got an E on it. These will only plug in one way, so you plug in the E there, like that. This one is X. This is the X axis. The plug-in for it's at the bottom. Not super easy to get to. Wow, not easy at all to get to. There it goes. This smaller one, this is the X also, but this is the X in stop. So there's a little trigger in here. And it's over here, but the plug-in for it is probably inside there. Yes, it's inside there. Again, it'll only plug one way, so you might have to get some pliers or something to reach in there and get it to plug in. Or you can do it that way. All right, and got one left here. This one should have a Z on it. Yes, a Z, and it's going to plug in here. I do need the Z in stop. I don't see that. Oh, it's out of the. It's right here. So the Z in stop will plug in right on the Z. The Z in stop is the one that we had to bolt on. All the others were already on there. And then the Z motor. Again, the Z in stop is the one I said we would probably have to adjust. Okay, there, and that is, well, there are these little covers which you probably do want to put in because these corners are actually really sharp. So these just snap in to the ends, except doesn't want to snap in. Maybe they have to hammer in. That way it rounds it off a little bit. I did get a cut on one of these corners as I was building it. All right, so I did notice that this wheel was not attached, which it goes down here. This is the bed leveling. It's rubbing up against that wire ribbon cable. That's how you level the bed on this by default, is you tighten there's 4 springs, one at each corner, and you tighten them down to create different heights for the bed. So if this is too high, you tighten this down and it'll bring that corner down. So we're kind of, what you would do next is you could power it on for one thing. We still have to worry about this Z movement. It's still not the way it should be because we're really sloppy over here. So we're going to have to work on those adjustments. You want to level your bed. So basically you put it in the 4 corners and you can kind of hear. That's the Z and stop triggering. So it looks like I'm going to need to raise the Z and stop a tiny bit. So now it's all of the little pieces of getting everything level and moving right. I'll save that for Wednesday, or not Wednesday, Tuesday. Let's turn it on and make sure we don't have any major problems though. So all that requires is plugging this guy in over here, plugging it into some power. And I do have all these cables still that I haven't really managed. Now this one, there's a little connection back here that you can snap it into that will kind of keep it out of the way. All right, the screen came on. That's good. They've got their own little splash screen on here. Oh, I think there's a cover. Is there? Can't tell if there's a. Yeah, there is. Let's put that over there. All right, and then there's our startup screen. I wouldn't do a whole lot just because nothing's tuned yet, but we can go in and just see if our axes move. So let's move Z 1 millimeter increments. So see, it's trying to move the Z axis up. Again, this is still floppy over here, so it's not going to do it correctly. We'll have to work on that. But it did move, so that's good. Move Y is the bed. All right, that moved, good. And then we'll move X, which is this guy. Yep. All right, so we have motion everywhere. We've just got to tune things up a lot. It would not print, I don't think. Mainly it wouldn't print right now because of how sloppy this is. We got to get that better. And we haven't leveled the bed. But other than that, it's capable of doing all the movements it needs to do to move into print. So on Tuesday we'll come in and I'll probably work on at least cleaning up some of that kind of slop and show you what I did. I'll level the bed in class so you can see how that works. And then we'll print, and I don't know what, I've got something else planned also. Maybe more on the slicer, on how you actually slice parts. But we'll come back on Tuesday. And hopefully on Tuesday we'll be able to do some of the Zoom meeting also so that you can ask more questions. Thank you for asking some questions in the chat though. That helps out so I know what you're thinking. See y'all on Tuesday.